Hey everybody, welcome to Externalities Part 2. This is a mostly math-free example of externalities and some of our policies to deal with them. In Part 1, I outlined 4 kinds of externalities: production and consumption externalities, positive and negative. I showed where the deadweight loss is on each graph. I explained the conditions under which a market is efficient. And then I told you that in this video, I would start to outline some of our policy options for combating externalities. That's what I'm going to do here. Let me start by taking this graph, and let's just put some labels on it. On this graph, I'm just going to do everything by ones. So we've got a choke price for demand on 15, a choke supply price of 1, market quantity is 7, market price is 8. You get the idea. If we had math here, I would say that this is a private marginal benefit curve was 15 minus Q, and the private marginal cost was 1 plus Q. And for our scenario, let's add an external cost of 4. So for every unit we produce, there's an extra cost of 4 that is not being accounted for in our market, and it's affecting someone else outside of the market. So our social marginal cost is the private marginal cost plus the external cost. We explained that in the last video. It's a view of all of the costs to society from this market. And so that'd be 1 plus Q plus 4 would be 5 plus Q. And so we can put that on the graph. Now, if you're in one of my sort of math-free classes, this graph would probably come to you already labeled. It would look something like this. And if you're in like my intermediate micro class where we cover some of this stuff, well then, here's the math you'd have to work with. Let's see if you can replicate the math based on the answers I find by looking at the graph. It's up to you. At this social marginal cost, we can find where it meets the private marginal benefit, and that's at a quantity of 5. And 5 is the optimal quantity, because it's the quantity where our social marginal cost meets all of our marginal benefits. Remember our optimal outcome, marginal social cost equals marginal social benefit. And in the absence of an externality, private marginal benefit is social marginal benefit. So this intersection gives us our optimal Q. I told you this is going to be about policy and some of our policy options. I'm going to ignore the possibility of just ignoring this externality. So that would be a no policy or a non-intervention policy, which is fine. But I'm going to set a policy goal of making the market efficient. What would it look like trying to make this market become efficient? Well, that would mean I'm trying to get from this market Q of 7 down to the optimal Q of 5. I'm trying to slow down this market from 7 to 5. That is the goal if I'm trying to make this market be efficient. And based on that, I have 3 main options here. One of them is I can promote a private solution to our problem. I can invoke the Coase theorem. I'll explain that in just a minute. 2 is I can do quantity interventions, such as regulation. Regulation might be something like a quota, maximum production of our good, or a cap and trade is another version of quantity interventions. And the third option is price interventions, like a Pigouvian tax or subsidy. And so I want to take just a minute to explain each of these. So in this video, I'm just going to explain what the different interventions are and like what levels we'd want to set them at. And maybe in another video at some point, I'll make one explaining when one might be better than another. But for now, I'll leave that to you. So promoting a private solution, what does that mean? Well, the Coase theorem basically says that if there are well-defined property rights, if you make someone responsible for the externality, then the market can sort itself out, because the sellers and the buyers in our market will interact with the people who are being affected by the market, and they will all come up with a solution between themselves. So this could be allocating property rights. This could be creating a better, part of that could be creating a better legal system where it's easy to find redress for damages. But that's pretty much it. So the thing about the Coase theorem is that it's really good if there's low transaction costs. If it's easy for all the different parties in the market and out of the market who are involved to negotiate with each other. If it's easy, cheap bargaining, then the Coase theorem can work. So an example of two neighbors living next to each other in an apartment complex where they're negotiating about how much noise they make at what times of day, that can be like a Coase theorem kind of solution. It works with small numbers of people who are connected to each other. It doesn't work as well when there's tons of people or when the costs are hard to measure. For instance, traffic congestion or pollution and global warming or whatever it might be. It just doesn't work very well if it's hard for people to negotiate with each other. Quantity interventions, we have a couple of choices. One, we could do a regulation, and I chose an example of a quota where we could take this market queue of 5 and just divide it up among the existing firms and say each firm is not allowed to produce more than their share of Q star. It's a very arbitrary regulation, but it limits the aggregate production to Q star. This will affect some firms differently than others based on their cost function, and so it will have a bigger cost to some firms than for others. So something like this might actually end up choosing some winners and losers somewhat. But it is a very simple way to reduce the quantity to the efficient quantity, assuming you know the efficient quantity. Of course, with something like this, there are enforcement costs because you have to be able to monitor the firms and have an apparatus in place to enforce the law. Cap and trade is very similar in spirit because it's also about dividing up the queue. But instead of just telling each firm how much they're allowed to produce, we're going to introduce more of a market system. So one example of dividing up the Q star would be issuing 5 permits for 1 unit of production each. So there's 5 permits for the 5Q, so it's got the Q star aspect. But then we let the firms buy and sell the permits. And the firms who benefit most from producing this good can buy the permits from the firms who benefit less. And these permits will get allocated to the firms that value them most. And there's all kinds of questions we could ask about how are the first 5 permits issued? Are they issued at auction? Are they issued randomly? Are they issued evenly? That's a whole bigger can of worms, a bigger discussion for a bigger day in an environmental econ class. But anyway, the cap and trade, it takes the idea of like a quantity quota type deal, but then breaks it down and allows you to allocate that quantity as efficiently as possible. And our last option is a price intervention. And I'm going to use the Pigouvian tax example. We tax during costs to make bad things more expensive, and we tax when there's external benefits to make them less expensive. So in this case, we would set the tax equal to the external cost, be equal to 4. And if there had been an external benefit, we would set a subsidy equal to that. Now, I do want to explain, I think the quota and the quantity are pretty obvious why we did 5 here. But let's talk a bit about the tax of 4. Well, between these two lines, the gap is $4. And so if we put a tax on the firms of $4, I will start with this exact same curve. I'm going to shift it up by $4. 1, 2, 3, 4. This curve is like private marginal cost plus the tax, which if we set the tax equal to the external cost, is private marginal cost plus external cost, which is the social marginal cost. By setting the tax equal to the external cost, we force the firm to internalize the externality. It makes it so that they operate on this red line, this private marginal cost plus the tax line, which if we set our tax well, will equal the social marginal cost at the social optimum. Now I do want to give some loose ideas for when these things are for when one of these might be preferred over another. With a global pollutant like greenhouse gas emissions, something like cap and trade or a tax would be an efficient outcome. They both can limit the quantity to Q star, but they do it with market incentives so that they create the least distortion possible in the marketplace. But with something like a firm poisoning the river or letting mercury get into the groundwater supply or something like that, some sort of local pollutant, it's often not advisable to let a firm be able to buy the rights to extra pollution because that concentration of pollution is very damaging. So in the case of a local pollutant, we're often more interested in something like a quota where you just limit the quantity. So there's all kinds of stuff we can get into with global pollutants versus local pollutants. We can get into issues of uncertainty. And if we're not quite sure what the cost is to the firm, then maybe one of these will be preferred to the others. And a lot of it kind of depends on the benefits from reducing pollution. There's a whole lot we can get into. But I think this is a pretty good starting point. So yeah, I guess that's it for this video. Thanks for watching, guys. Good luck and happy econing.